What if I told you that the chaos in Las Vegas was so severe that F1 teams went directly against the FIA, and the truth behind that red flag is far worse than anyone is admitting? You saw a simple interruption on television, but the reality is that cars were running at full speed over a piece of track infrastructure that was literally moving under them. And just when you think it cannot get worse, Lewis Hamilton's Ferrari suffered problems that exposed something deeper inside the SF25 that nobody wanted to talk about. Stay right here, because what happened in FP2 could force the FIA to rewrite its entire safety protocol, and once you hear it, you will understand why every team exploded in anger. The core problem that exploded in Las Vegas during FP2 was not merely a routine session interruption but a collapse of trust between the teams and the governing body. When a track surface fails twice in the final stretch of a practice session, especially on a street circuit that had already suffered an international scandal 2 seasons earlier, the reaction is not simple frustration but genuine alarm. Teams depend on the FIA to guarantee that the environment in which they operate is fundamentally safe, and what happened in this session demonstrated the opposite. Formula One cars were circulating at speeds above 300 km per hour over a surface element that the FIA declared safe only minutes before it failed again. That is the kind of systemic breakdown that forces an entire paddock to question procedural competence at the highest level. The sequence of the first red flag revealed the early cracks. When the marshal reported a possible loose manhole cover near turn 17, the FIA halted the session and inspected the area. Their statement insisted that the structure was secure and the track was safe to resume, yet this reassurance lacked the dynamic testing necessary to simulate the load of a real Formula One car. Resuming the session after only a short evaluation gave teams the impression that the decision was rushed. And in a championship where details are measured in thousandths of a second, the idea that safety protocols are being executed with haste rather than thorough precision was enough to ignite a wave of suspicion even before the second failure occurred. What followed in the second red flag amplified that suspicion into outright anger. When personnel stationed at the same manhole moments after the restart reported visible movement under the pressure of passing cars, teams realized the earlier inspection had been incomplete. This was not a marginal issue. It was the same type of failure that destroyed the Ferrari chassis in 2023 and caused widespread condemnation of the circuit's infrastructure. To witness the same weakness return 2 years later, after countless promises of reinforced structures and new inspection standards, created the sense that lessons had not been learned. The problem was no longer the manhole. The problem was the credibility of the governing body tasked with preventing these failures. For Lewis Hamilton, the problem took on an additional dimension, because his SF25 was struggling to generate consistent grip even before the red flags appeared. The cold asphalt and the unique characteristics of the Las Vegas street layout exposed the narrow operating window of the Ferrari package, leaving Hamilton with a car that reacted sharply to temperature swings and surface inconsistencies. The red flag interruptions only worsened this behavior, preventing the tires from reaching their thermal window and forcing Hamilton to restart his preparation without rhythm. By the time he attempted his push runs, the car felt disconnected, which magnified the gap to his teammate and left Ferrari without the data they desperately needed to stabilize the setup for qualifying. The combined impact of the track failures and Hamilton's stiffness with the SF25 created a situation where Ferrari could not distinguish between problems caused by the environment and problems caused by the car itself. Engineers rely on clean laps to read aerodynamic balance, tire behavior, and mechanical response, yet the constant interruptions denied Hamilton the opportunity to build those references. Every time he exited the garage, the tires cooled rapidly, the balance shifted and the car reacted unpredictably in the medium-speed corners. This made diagnosis nearly impossible and pushed Ferrari into a reactive mode rather than a strategic one. For a driver attempting to extract confidence from a machine that has challenged him all season, this was the worst possible scenario. And at the heart of the frustration shared by teams and drivers was a single question that no one on the grid could ignore. How could the FIA declare a safety element secure when the personnel standing beside it observed dangerous movement only minutes later? This is the question that shaped the entire mood of the paddock and the question that determined the tone of the night in Las Vegas. If you were standing on the pit wall watching your driver approach that corner at full speed, would you have accepted the decision to restart the session, or would you have demanded a full structural review before allowing a single car back onto the track? Your answer reveals where you believe the line between safety and risk should be drawn in the most unforgiving sport in the world. The engineering challenge that erupted in Las Vegas pushed teams into a crisis mode that few expected to experience this late in the season. When the manhole near turn 17 showed signs of instability under full load, engineers understood immediately that this was not a simple surface defect but a structural failure capable of altering the aerodynamic behavior of any car passing over it. Formula One machines rely on millimetric consistency in the track surface to maintain stable downforce. Any deviation, even a movement measured in millimeters, can trigger oscillations that damage the floor, disrupt airflow, or destabilize the chassis mid-corner. The moment the FIA confirmed that the manhole had shifted under load, engineers knew the session had become useless for gathering representative data and that the safety margin had narrowed to an unacceptable level. Inside the Ferrari garage, the response was even more complex because the SF25 had already shown clear sensitivity to vertical load changes throughout the season. The cold temperatures in Las Vegas reduced tire energy dramatically, forcing the team to raise ride height to protect the floor and prevent plank wear. This compromised the aerodynamic platform and limited Ferrari's ability to lock the car into its ideal performance window. When the track infrastructure itself became unstable, that delicate balance was disrupted further, giving engineers contradictory readings between runs and leaving Hamilton with a car that felt inconsistent from corner to corner. He reported sudden losses of grip on entry and unexpected snaps on acceleration, symptoms consistent with a platform that was not receiving a constant load signal from the surface beneath it. The second engineering obstacle came from the session interruptions themselves. Every red flag reset tire temperatures, brake energy, and battery deployment strategy. For a car like the SF25, which requires multiple preparation laps to bring the tires into their temperature window, these resets were catastrophic. Hamilton repeatedly left the garage with tires that had fallen below optimal temperature thresholds, forcing him to push aggressively to build heat. But the aggressive preparation laps risked damaging the surface of the tire, especially in cold conditions where graining becomes a major threat. The timing of the red flags meant Hamilton never completed a sequence of laps long enough to stabilize grip, leaving Ferrari with incomplete data and a driver fighting the machinery more than the circuit itself. The chaos also exposed the limitations of Ferrari's simulation models in predicting tire behavior under the unique conditions of Las Vegas. With the humidity from the earlier light rainfall blending with the cold desert air, the grip curve of the asphalt evolved in ways that the models had not fully anticipated. Engineers attempted to compensate by adjusting differential settings, brake migration, and energy recovery maps, but without uninterrupted running, each adjustment became a guess rather than a guided correction. Hamilton's feedback was precise, describing exactly where the car lost stability and how the rear end stepped out during directional changes, yet even that expert input could not overcome the lack of proper data due to the repeated interruptions. Another layer of engineering tension arose when Hamilton encountered Nico Hülkenberg in the final sector at high speed. The near collision reflected not driver error but a deeper mechanical issue related to visibility, depth perception, and closing speeds. The extreme lighting contrasts along the Las Vegas Strip combined with the enormous speed differential between out laps and push laps created a scenario where a slight misjudgment could have led to disaster. Engineers reviewing the telemetry noted that Hamilton had been on a strong preparation sequence and was finally bringing his tires into a usable temperature range when the incident occurred. Losing that momentum meant losing one of the few windows in which the SF25 was in a potentially competitive state. What the data showed clearly was that misfortune compounded misfortune, leaving Ferrari technically cornered. By the end of the session, the engineering team faced a paradox. They had collected a huge quantity of telemetry due to the repeated runs, but almost none of it was representative. Tire temperatures were inconsistent, grip levels fluctuated wildly, and aerodynamic load readings were skewed by the unstable track surface. Hamilton's engineers were forced to abandon several planned setup pathways and rely instead on cross-referencing earlier sessions from other circuits with similar temperature profiles. The result was a night of intense analysis, uncertainty, and recalibration. And this leads to the central question for anyone who follows the sport closely. If you were responsible for defining the technical direction after a session dominated by interruptions, contradictory data, and safety issues, would you trust the limited information from FP2 or rebuild the entire approach from scratch for the next session?